Good afternoon, everyone. We're ready for the next session from Tyler Paxton on the secure metamorphosis streaming logs with Kafka and TLS. Welcome.
All right. All right. Thank you. Let me get this working. All right. Today we're going to talk a little bit about Kafka. The few things that I'm going to run through are going to be just a quick introduction of myself, the data that we deal with, what Kafka is, and what the security considerations are for Kafka, how to secure Kafka, and then some of the lessons that we've learned as we've been doing that at our organization. They asked me to do this as a reminder. There is a Slido, and then that's the tag for the room. If you want to have questions, then we can review those at the end. So I work for Distill Networks. We protect against automated threats. I'm a product manager there. I'm responsible for our research and our data. So we have a lot of data that flows through. We sit as a layer 7 inline bot mitigation. And some of the things that we protect against are people that might be doing account fraud, web scraping, trying to do card cracking, or any other type of abuse that you would use an automated piece of software to do. Because of that, we have a ton of data that we collect. We use the data for monitoring our systems, for visualizing the data, for doing detection, and then also use that to provide professional services to help consult with our customers. So some of the pieces of data that we have are we have web, mobile, API protection. We do browser interrogation. We have a mobile SDK, and all of that data flows into us, and then we consolidate that and use it for those various purposes. We take in about 5 billion messages per day, and it's just growing rapidly. So our messages are typically in some sort of structured format, like a protobuf or JSON, but we have them coming in various formats depending on the different parts of the system. So these are an example of some of our producers. There are different ways that you can integrate with Distill. We have a global CDN. You can have your own virtual private cloud. You can have a dedicated device in your infrastructure. You can take our connector and install it into your application. And then in addition to those are constantly reporting telemetry, access logs. We also have the browsers where we have JavaScript that goes to fingerprint the devices so that we can track them. All of that data comes back to us and includes information about the browser. It includes biometric data that we're gathering to determine if you're a human or not. And then the same thing coming from mobile SDK, we've got that same sort of telemetry data. So all of those things produce logs, and there are a lot of different things we want to use those logs for. I've mentioned a few of them. Monitoring, we enrich the logs with additional information to make the analysis more complete. We use it to do machine learning and detection. It eventually all ends up in our data warehouse, and then that can be used for reporting in our portal for dashboards, and then also for our analysts to use. Now, if everything wants to get all of the logs without something like Kafka in place, a messaging broker, everything would have to be aware of where the logs were and try to gather them, and it gets pretty unwieldy and messy. And that's where Kafka comes in. So how many people, just for a sense, how many people here are familiar with Kafka or use Kafka? All right, cool. All right. So not this Kafka, the author. Instead, it's Kafka, the pub/sub message broker. So in Kafka, some of the basics about Kafka is there's two different types of clients. You have producers, they're the ones that are publishing logs, and then you have consumers, they're the ones that are consuming logs. Then they typically, the logs that are sent are considered messages. Those messages can be sent as individual messages or also sent in batch, so you can reduce how often you're calling out to the broker. The message schema can be varied. It can be whatever you want that you put into there. You can have no schema if you want, I guess. The Kafka organization is organized by topics. So you publish to a specific topic. You can also subscribe to a specific topic and consume those logs. Once they end up in a topic, the data is broken out into partitions. Kafka uses sequential writes to disk to get high performance. Those partitions are spread across multiple brokers, and then the consumers can go in a consumer group and consume from each of those partitions. And we'll take a look at just real briefly what that looks like. They then use an offset so you know where in the log stream you're consuming. And that way you have some failover redundancy if you need to go back and reconsume. And each consumer group has their own offset so they know where they are in the stream of data. So this is sort of what it looks like. On the left, you have the producers. On the right, you have the consumers. They publish in. They'll go to a leader broker for each topic. That leader broker can replicate the data so that if one broker dies, that data persists. And then the consumers consume from the lead partition for that topic. This is an idea of just what the partitions look like. Logs are just being sequentially written at the end, and then you just know where you are in consuming those logs. All right, so with Kafka, you have Kafka itself, but then you also have, and the brokers within that, you also have Zookeeper. Zookeeper is used to help orchestrate the work that the brokers are doing. So Zookeeper is just a distributed open source coordination service, and this helps you make sure that you're coordinating services across each of the brokers. It also manages a couple of other things that we'll talk about, like access control list and some of that. So with Kafka in place, instead it can look a little bit cleaner like this. You have one Kafka service, obviously with multiple topics. It might be a little bit messier than that. You're not going to have just one topic everything's going to push to. Otherwise, you're going to have to spend a lot of time parsing those logs, figuring out which of them you need to consume and throw away. So you can segment them so that you're only consuming, each service is only consuming the logs that are important to them. So today we're going to talk a little bit about securing Kafka. Some of the reasons you might want to do it is just for good security hygiene. You might have some requirements around compliance for PCI, GDPR, for PHI, like HIPAA. And then you also want to just avoid any problems you might have. If you just let anybody publish, you could have abuse and contaminated data. So there are several things that you need to consider when you're using Kafka. The first is that you're encrypting the data in transport. So that is data that's coming from a producer into the brokers or out of the brokers to the consumers. And then also from server to server as well. You also have authentication, so you want to make sure that you're authenticating the clients that are communicating with you. So a client, in this case, I'm going to use the word client, and when I say client, I mean either the producer or consumer. Authentication, again, just make sure that you're communicating with who you intended. You also have encryption at rest, and this is to ensure that the data is protected while it's being stored on disk. And then you have authorization. So you might have encrypted communication, you might know who you're working with, but you want to limit them to certain privileges within the service. So out of the box, just within each of these, so transport encryption, all messages out of the box are sent in plain text by default. Authentication, there's no authentication required by default. Encryption at rest, there's no special accommodations made for Kafka, within Kafka for it. We'll talk about what options there could be. And then for authorization, again, open by default. So let's take a look at some of these. The first thing we're going to look at is the Kafka defaults, just to take a look at what that looks like. So in here, the only thing that I've changed is instead of listening on any address, I've changed it to just listen to my Kafka service. This is just a single EC2 instance. You can see that I'm listening on plain text on port here is 9092, and then Zookeeper is on port 2181. We'll talk a little bit about securing Zookeeper and the challenges there. Again, there's no default authorization or authentication, so that means that anybody could create or delete a topic. So what that would look like is here I have a sample Kafka client that I've connected to my Kafka service. I've just asked it to create a topic. There's no authentication going on here, and once I've done that, I get a created topic and everything's happy. Again, this is just what it looks like out of the box. And any client can connect, and any client can produce messages, and anybody can consume messages. So up here on the top, this is my producer. I'm going to connect. I get the little I get my chevron. I can type in. If I get another chevron that confirms my message was published, and we can see that being consumed on below from my consumer. Again, they're in transport. That means that we can see everything that's being sent. That means it's prone to sniffing and tampering, and other PII can be exposed. So here I have, again, let's say I'm sending social security numbers across the wire using my publisher. If we send those, then I can just, I'm just listening on anything that's going to my Kafka server, and I can see in the bottom right my social security number showing up. That is not my actual social security number. So Kafka transport encryption. Kafka just has normal transport encryption through TLS. You can set it up as either one way, meaning that the clients only need to encrypt what they're sending to the brokers, or you can set it up as mutual TLS. It supports TLS 1.0, 1.1, and 1.2. What this looks like is a quick TLS overview. Is on the left I have a Kafka server. On the right I have a Kafka client. The Kafka server is going to have a key store and a trust store, and the Kafka client in this example is only going to really need the trust store. The Kafka server will have a signed certificate from our certificate authority or your certificate authority. The Kafka client will have the public certificate. And then when the Kafka client wants to initiate communication, they'll get back the signed certificate, they'll validate it, and then they'll initiate secure communication. This is an overly simplified version of TLS. So let's take a look at that, what you need to do to set Kafka up to have this one-way encrypted communication. First, you need to identify your CA. So hopefully you have a CA at your organization, or you can create your own CA, and I'm going to do that in my examples here. You'll generate a key store on the server. You'll generate a Java key store. You'll generate a new key. You'll generate a server request, get that signed server cert from your CA, and then install that server cert into your key store. Install the public CA cert into your key store, and then generate a Java trust store and put the public CA cert into that trust store as well. Then you'll need to go into Kafka and configure the server properties, and then you'll need to ensure that the SSL port that you've configured is open, and then you can go ahead and restart your server. So let's go through those steps really quickly. I'm going to blast through these because this is all normal, just like CA cert stuff, but just for an idea, here I am generating a new key store. Within that key store, I'm also going to just look at what I have in there after I generate a new key. I can see that I have a key for my host, kafka.tylerpaxton.com. And then I'm going to go ahead and import the root certificate from my public CA. And then I'm going to request a signed certificate using that public certificate in my key that's in my key store. So now I have a certificate request. I'm going to send that over to my CA. If you're paying attention, this same server also has my CA cert and key on it, so it's pretty easy for me to do. Normally, you would send this over to whoever it is that's responsible for your CA in your organization. So I generate that, and now I can verify my signed cert. I have a signed cert for my host from my CA, and I'm going to go ahead and import that into my key store. So now in my key store, I have my key, or I have the signed key and the cert from the public CA. So again, that's all pretty straightforward if you worked with any sort of encryption in the past. And then the next thing that we need to do is open up our server properties file. So in the server properties file, again, initially it was set up to listen on port 9092, and I'm going to configure it to listen on port 9093. I'm going to still listen on port 9092 as well. You can have both in place. Obviously, that's not, it's not going to be secure, but I'm going to use that just as I walk through my examples. You could eventually remove that, or if you want to not have interbroker secure communication, you would need to continue listening on port 9092 as well. There's some additional configuration settings that I have here that point to where my key store and my trust store are, and have my passwords for them. The last thing that you can do, this is an optional setting, so you don't have to set this, but you can set the protocols that you'll allow. So ideally, you would limit it to TLS 1.2. You could do 1.1 optionally as well, hopefully not 1.0, as it's no longer considered secure. The next step is to open up your port. So I'm going to open up my port for SSL so I can allow secure communication and accept incoming requests on that port. So now that I have my server set up, the next thing that I'm going to do is set up my client. On my client, I want to go through, and I just need to generate a trust store here, so only a trust store in this first step, unless I'm doing mutual TLS, and we'll get to that. I'm going to import the CA public cert into that trust store. What that allows me to do is confirm that the signed cert was signed by my trusted CA, and keep that chain of trust. The next thing that I want to do is set up the client properties, and then change my connection information to include those client properties in them. So again, creating a trust store using QTool. I have now I've imported the CA public certificate into my trust store, and then I'm going to go into my client properties, and I'm going to set the security protocol to be SSL, and point to my trust store and give it my password. So now that's all set up, I'm going to save that into a file called client properties, and in my connection information, I'm going to create a topic. And you'll note that when I'm creating my topic, I'm pointing to not the, I am pointing to, sorry, I went one slide too many. There we go, right there. So when I'm creating my topic, I am pointing to the Zookeeper port. So Zookeeper is responsible for creating the topic. So even though I've enforced SSL, I've set that in my client properties, I can still create topics at will. But if I want to connect to as a producer and want to produce on my new topic called Kafka Secure, I need to pass in the parameter for my client properties file, and now I'm able to successfully produce messages to my Kafka broker. So let's take a look at what that looks like. Here I have the Kafka broker with the client properties passed in. My consumer does not have it. And it is still listening on port 9092. So in this example, I have both in place. I'm encrypting messages as I publish them, but when I consume them, they're not being encrypted on the way out. So still not quite what we want. So I'm going to update my consumer connection to have the same properties. I'm going to use the same properties file. And in this case, my consumer and my producer are both on the same box, so I'm just using the same properties file. I'm going to update my connection. And now that I'm connecting over both on port 9093 on both of them, I'm able to both encrypt as I publish and encrypt as I consume. All right, let's take a look at the next thing, Kafka Authentication. So within Kafka Authentication, this is going to authenticate the clients that we are communicating with, we trust. So we already have the CA public certificate in our trust store. So now we just need to get a signed certificate to the clients. So once we have the signed client certificate, that enables us to have mutual trust, and then we can have secure communication. To do that, we'll configure the Kafka to require Kafka server properties to require authentication when connected over when we're using SSL. There are a bunch of other optional parameters that we have here. So within the client, we've already talked about generating a key store. I'm going to skip through these pretty quick and just look at here we have our certificate, our signed certificate. We install it into our key store, and now we're going to update our client properties to include the key store in the client properties. So now I've actually changed this. This is SSL auth properties, so I'm going to start using that in my connection, and I'm going to use that in my connection as well for my consumer. Again, still communicating over my secure SSL port. So in this example, now I have mutual TLS. I know as a client that I'm communicating with the server that I want to, and I know as a server I'm communicating with the clients that I want to. So what are some of the lessons that we've learned here? A couple of things that we found is that Java is very slow, especially in 1.8. So we got significant increases in performance by going to Java 1.9. Zookeeper, as I mentioned, doesn't support TLS. So to enable secure communication between them is either going to take a lot of effort, or you'll want to take other measures to help secure Zookeeper. And then another thing that we learned was that we wanted to confirm the Cypher Suite compatibility with the different client libraries that we're using. Our producers actually have a Go Kafka library called Sarama. It only supported a subset of Cypher Suites, and so we just needed to go through and ensure that we were using one of those that was compatible. Other things we learned is that this is just really tricky to automate. I'm doing it on one broker and just one consumer, one publisher. You get a lot of keys. You're going to want to have some sort of PKI management. And the other issue that you have is if you issue these certificates, there's no easy way to revoke them. There's nothing in Kafka to ensure that. So to ensure to do that, there are a couple of options that are outside of Kafka that you can pursue to support to use the native Java certificate revocation list. All right, jumping into authorization. So authorization is the next level. This is when we want to do additional authentication of individual users, and then we want to manage what those users have access to. Ideally, you're doing authorization between all your brokers, from your brokers to your Zookeeper, and from your clients to your cluster as well. Authentication comes in a few flavors. There's plain. This is just a simple username password. There's the salted challenge response and authentication mechanism, which is, again, username and passwords with a challenge or a salt. And then there's Kerberos, which is a ticket-based authentication, and it would be the recommended option to pursue. Kerberos is a pain, and so it's going to be painful. Hopefully you already have Kerberos set up and you can leverage that, and you have an expert somewhere that you can rely on. Today, I'm going to walk through just doing plain authorization so that you can see what that looks like. For that, we're going to have to update our listeners. We're going to have to enable SASL and then choose the broker protocol, and then configure the Java authentication authorization service, and then add users to that. And on the client, we're just going to need to change the client properties to include the username and password. So what that looks like is where before I had plain text and SSL. I've changed SSL to be SASL_SSL. And then I have a couple of additional server properties here telling it which type of SASL to use. And I'm also telling it to use SASL authorization between brokers. And we're not going to be able to see that today because, again, this is a single broker cluster. So you can add the Jazz config to your server properties, or you can have it in an external file and point to that. We've had some issues just pointing to an external file and found that it was a little bit less troublesome to put directly into the server properties. If you want to do that, this is what the Jazz configuration would look like. So in the server file, I'm just going to add the listener. I'm going to put a listener config on the listener name that I want it to be on. And then the other nice thing is if you use the external Jazz file, you can include that in Kafka Ops, which is an option that runs all the time and just starts out blank when you're starting your Kafka brokers. So this is what I've created a user. I've called it Kafka client, given it a password. Now I have a password, and I'm going to include that in my client properties. So, and I've told it also to use SASL in the client properties. So I also created a bad password, and I'm going to go ahead and test that out. So first I'm going to try it with the wrong password properties file. And we can see that I get an error saying I have an invalid username or password. So before, when I had, that's one of the nice things about using the authorization is you get a little bit better messaging around if you're not able to successfully connect. I don't know if, I can't remember if I had an example, but if you were using just encrypted TLS and you connect and you try to produce, you don't get any message back telling you that it didn't produce or why. All you get is just that it didn't produce. It doesn't produce. So this is a little bit better for troubleshooting. Now I'm going to change it to the correct properties, and here I'm going to go in. Let me hit play manually. So now I'm going to go ahead and connect, and in this case, now I'm authenticated using my username and password, and the messages will publish. So now I have authenticated messages. The only thing here is now my publishers and consumers can read on everything. Everything is open to the world. So now I want to go in and add some access control list. To do that, Kafka ships with the pluggable authorizer. The ACLs are stored in Zookeeper. Typical operations, read, write, create. The resources include the topic, the cluster, and then a consumer group. Here's some examples of those. I'm going to jump through a little bit. To do ACL configuration, you're going to edit your server properties. You're going to add the authorizer, add super users, which is an important step. It's really easy with Zookeeper ACL management to, it doesn't append, it's going to overwrite. So it's really easy to wipe out the authorization that you've set up. And then we're going to add some ACLs and edit the client properties. So here I'm adding the authorizer. I'm setting up a super user, and I'm going to go ahead and try to connect. We see here that I was unable to connect because I have no authorized access now to Kafka Secure. So because I've set up, I've added the user, I'm connecting with the user, and I haven't added any ACLs, I'm not able to do anything. So same thing on the client, I'm not able to access the topic. So I'm going to go ahead and I'm going to first create a user, a wildcard user. There are no groups in these ACLs, so you can either do wildcards or specific named users. And then I'm going to set that up to be able to, any user to be able to read from my Kafka Secure topic. We see that takes, and now my consumer, you can't tell here, but I've started my consumer, it's consuming, I don't get an error message, but my producer does get an error message that it can't access the topic to produce to it. So now I'm going to go add for Kafka client, my user that I set up in my properties. I'm going to add the operation write. I'm going to make sure that that takes. And then now I can see that I have secure messages that are authenticated, authorized, appropriately. So some of the lessons that we learned here, again, Kerberos is a pain. I can't say it enough. ACL changes, I talked about those being overwritten, making sure to set up a super user. There's also, if you do end up doing ACL management using Sassel Plain or Sassel Scram, you would, there is a tool that helps manage those ACLs and has also appropriate auditing in place for that. So that'll be useful. Another thing to consider is that Kafka is responsible for the ACLs. It has some metadata in there, so you want to separate out Zookeeper and limit access to it. And then for encryption at rest, really the best option is just to encrypt your file system. And if you're doing it in AWS, you can use encrypted EBS volumes, or in HDFS, you can encrypt there. A couple of resources. There's all the documentation. It's dry as you'd expect, but really thorough and helpful. And if you're doing it in AWS, there is a best practices for that. There's also a couple of things that I'd recommend. One is the O'Reilly Kafka book, and then there's a course by Stefan and Gerd. I'm not going to attempt their last names, but they have a Kafka security series. It's $15, super thorough, helps you get through setting up a basic setup. So I think I'm out of time, and I don't have any time for any questions right now. So I apologize, but if you want to find me, I'm happy to jump in and answer any specific questions that you have. Thanks, everybody.
Thank you, Tyler. There was one question: what is the relation with Kafka and GDPR? So maybe that's something that you can.
Oh, sure. Yeah. So just for GDPR, you need to keep track of PII, and you need to ensure that it's secured. So for us, it's just ensuring that our data is encrypted in transport. Oh.
On behalf of BSides, we thank you for your presentation.
Thank you. Appreciate it. Thank you, everybody.